Hi, this is Mrs. Tratner, and this lesson is on sound waves. These are the objectives that we've been covering in the unit. The goals for today is to calculate the speed of sound and also determine how sound travels. So when we talk about sound, you've probably heard the old saying, if a tree falls in a forest and no one hears it, does the tree make a sound? Well, the answer to that would mean that the person would actually have to hear it, even though that there is sound being made, because sound is a disturbance that travels through a medium as a longitudinal wave. Okay, so when we make sound waves begin with a vibration, and it vibrates the air very, very rapidly. And because it is a longitudinal wave, the wave, remember, will compress and rarefact. Okay, it's like the spring. And we know that sound waves need to travel through a medium like water or air or something like that. So sound can travel through these three types of mediums: air, liquids, and a solid. We know that sound can travel a little bit more quickly through some mediums than in others. So when sound waves interact with different mediums, they'll do a couple of things. They can pass through the medium, like through air or through another gas. Sometimes those sound waves are reflected back. Sometimes those sound waves are diffracted, and sometimes they interfere with one another. So sounds can overlap one another. They can go around a barrier. They can hit the barrier and bounce back. Very similar to the virtual lab that we did when we looked at water, sound, and light. And we're going to look at in class another virtual lab just with sound. Now, the speed at which sound will travel will depend on three factors: elasticity, density, and temperature of the medium. So how movable is that medium? The elasticity, the density of the material, and the temperature of the material. So if we looked at this chart, you can see that through air at 0 degrees Celsius, it moves at 331 meters per second. The air at 20 degrees Celsius moves a little bit faster at 343 meters per second. And you can see the different speeds at which that sound will move. And 20 degrees Celsius is about room temperature. So that just kind of gives you kind of a starting point. Now, some other properties of sound would include the amount of energy, the distance, and the pitch of the sound, and the Doppler effect. So when we're talking about energy, the greater the amount of energy used to make a sound, the louder that the sound is. Okay, so less energy, less loudness. Distance, that makes sense, right? How far you are away from the sound will depend on that intensity or the loudness. Pitch is the sound that you hear at the frequency. So there are high pitches and there are low pitches. Okay, like if you think about it in terms of music, somebody who can sing very, very high has a high frequency. Somebody that sings very low has a low frequency. So pitch is the frequency of the sound wave. The Doppler effect, I'm sure that you've heard this. It's, when you hear a siren, okay, sometimes it sounds like a whirring sound, whir, whir, whir. So the Doppler effect is when the sound source is moving. Okay, so like on a fire truck or an ambulance. Okay, even like the tornado sirens, because that tornado siren will rotate. So the frequency of that sound changes because the source of the sound is in motion. So the people right by the fire truck hear a higher pitch frequency than the people that are behind the fire truck because that fire truck siren is moving. Now, loudness, I mentioned that before when we talked about energy. Loudness is the amount of energy that is needed to produce that sound, the distance that you are from the sound, the intensity, and the decibels. So the amount of energy makes sense. How much energy does it take to make that sound? Distance, the closer you are to that source, the louder that the sound is going to be. The further away you are, the quieter it's going to be, or the less loud it's going to be. Intensity is how intense is that sound? Is it a greater intensity or a lower intensity? So the amount of energy that a sound wave carries per second is the intensity. So it's really based on energy and distance. That's how they measure intensity. And then decibels is what we measure loudness in. So normal conversation is about 40 to 50 decibels. Very loud music, like a rock concert, is 110 to 120 decibels. So they measure decibels just by comparing the different loudness of sounds. And each 10 decibel increase in loudness is 10 times the intensity. So every time it goes up 10, the intensity of that loudness increases by 10 times. Pitch. When we talk about pitch, we normally talk about pitch when we're talking about music. Pitch is specific to notes in music, like when you're singing or playing a musical instrument, that pitch will change. We measure that pitch in frequency, which is in hertz. High frequency, high pitch. Low frequency, low pitch. And then, of course, we can measure the loudness of that in decibels. So after we watch the recording here, we will be in class doing a virtual lab. Of course, all independent students are always welcome. I will post the link to the lab so independent students can also work on the virtual lab. And if there are any questions, let me know.